tšwelela wena
ke YouTube
ke live ga ke refresh tše tae ke le live ba like
go live boka ko YouTube
Evening guys, can you please confirm if you can see the screen and if you can hear me? I'm just waiting for your comments, then we'll definitely start with the lesson. Evelyn, how are you? Soli, I see you the first one to arrive today. The Amingo. Please confirm if you can hear me, guys. We all good. Evening, guys. We're going to work today. All good. Okay. We're not gonna do the live on TikTok, né? We're not gonna do the live on TikTok. But those who need to join, they should come and join on YouTube, né? Okay. Someone is saying something is wrong with the link, but now I have more than 50 learners in the session. So this tells me that I know what is wrong. It's your phone, boss, or your network, ne? Okay, so now we can start with the lesson. We're going to continue with what we were doing, but now remember it will be more for grade 11, and then as a grade 12 learner you need to work with us. This is good for revision. Remember that 60% of your question paper, it will be based on grade 11's work. So as a grade 12 learner, you need to sit in on this grade 11's session. You need to sit in. Topic today, we're going to focus on trigonometry. The next topic on paper 1, we're going to work on functions. I hope you guys can understand that part. So please make sure that you sit in, and we're going to use this as a revision. Right. So remember, most of the time when we work with the trigonometry, the most important part that you need to understand is the reduction formula. So we're going to apply the reduction formula to solve certain problems. Okay, right. So during the day we had something like where we were reducing the sign of let's say I have the sign of 125 degrees and I need to reduce this. How can I reduce the sign of 135? Please guys, trust me when I say this. If you want to master the trigonometry, it's best that you understand how to do the reduction formula. So this is very important. So to reduce this 125, I'm going to check in which quadrant is the 125. So we know that this is in quadrant. If I have a Cartesian plane, this is my 90 degrees and this is my 180. So can you see that 125 is between these two guys? So it's in quadrant 2. And what is going on in quadrant 2? We can write this as the sign of 180 minus. We need to minus an angle so that we can get what can we subtract from 180 to get 125. You just have to find the difference between 180 and 125. So this tells you that the difference will be 55. So this will be 55 degrees. We check, where is 180 minus theta? Second quadrant. How is sine in second quadrant? Positive. This will change in positive. Sine 55 degrees. Right. So now this is good now. But what about when they give you maybe a big angle to work on? Remember, there is a reason why I keep showing you guys this. What about if I want to reduce the tan of 660? How can we reduce this one? Because now we need to find in which angle, in which triangle is tan, is that angle 660. So the best thing that I'm going to do is to first, I know that I can write this as the tan of 360 degrees. Then I need to add something to 360 degrees to get 660. So what I need you to do is to find the difference between these two numbers. So when you find the difference, you'll find that the difference is 300. So we need to add 300. And where is tan of 360 plus theta? It is in quadrant 1, because this is my 360. If I add something, I'll go in that quadrant. If I subtract, I'll move in the other quadrant. I hope this makes sense. So now this is just the tan 300 degrees. So this is the tan 300 degrees. So now let's look at this. How can we reduce the tan? So we need to do the reduction formula again. We need to reduce the 300 again. So to reduce this, I'm going to check in which quadrant do I have 300, guys. We're just doing a homework. We're just doing a homework. Even when you go for a run, you just don't start with 180 with so much speed. We are still doing a homework. I hope everyone is with me on that. I think Sai is still preparing. Yes, and Tombizota, I was still preparing, guys. And I think the issue that we are starting lessons late is because I come back from work late. So when I come back from work, I prepare something fast to eat. When I say we'll start 0 o'clock, that o'clock becomes 15 minutes late, you see. Right. I think it used with angles like, oh, this one, you think that we need to, yes, that's correct. That's how we can reduce the 317 Tombizotwa. That's correct. Say, is this the beginning? Yes, this is the beginning. We're just doing the homework, ne? We're just doing the homework, okay? Don't worry, we'll go into much details, ne? So now look at this. If I have the tan 300, we're going to say this is the tan and this is in quadrant 4. So this will be 360. What can we minus from 360? We need to minus 60 degrees. So this will be the tan of 360. We're going to minus 60 degrees. And in which quadrant is this? How is tan in quadrant 4? Tan is negative, so this will be negative the tan of 60 degrees. Look at this. We just leave this one like this because 55 is not a special angle. So I'm just going to leave it like that. But now, when I look at this, I still have to do what? I still have to simplify this further by punching this on the calculator, and we find that this is negative the root of 3. And this is our final answer. So if you understand the reduction formulae, congratulations. Now you can be able to simplify. You can be able to simplify exam type questions. Right, you can be able to simplify the exam type questions. Okay, we're just gonna work on how we can use the reduction formulae to prove the identities. Now I'm just gonna also start you with a quick warm-up. Let's say I need to prove. So remember, during the day we talked about proving identities, right? So on proving identities, there are steps that we need to follow. Remember, the first step, make sure that you separate your left hand side and your right hand side. Make sure you know which side is your left hand side, which side is your right hand side, because when you can differentiate which one is the left hand side and which one is the right hand side, the second step, you need to start on the more complex side, the one that is more complicated. You work on it, then you prove that the sides are equal. So what I'm trying to say, if I want to prove the cos squared x times the tan squared x, so if I want to prove that this is equal to the sine squared x, what should we do? We need to check between these two which one is the most complicated side. So I'm just gonna go with my left hand side and I'll write it down and say this is my cos squared x multiplied by the tan squared x. So now I know that this has to do with what? The identities. Where I see tan, if I have the tan of theta, I need to subtract this with the sine theta over the cos of theta. And just like that, I can see that where there's tan squared theta, I can separate this and say this will be equals to the cos squared x multiplied by the sine squared x over the cos squared x. Look at this. The two cancel. I'm just left with what? The sine squared x. Therefore, left hand side will be equals to right hand side. Guys, please tell me if I'm moving fast. Ne? Tell me if I'm moving fast. Okay, coconut is try. It's asking if we can try one alone. It's fine. I can give you something to try. Ne? Let me give you something that you can try on your own. Let's say work on this first. Ne? Work on this first. The tan x plus the cos x over 1 plus the sine x. It's equals to 1 over the cos x. So I need you guys to prove that your left hand side is equal to your right hand side. You can work on that. Let's see if you guys can get it right. I need to see the comments, guys. I need to see your comments. Let's see how far we are. Did you even attempt the question? $60 plus 90, 35, which will be cos 45. So why is it? Because I don't think we can change sine to cos when it's 35 degrees. Guys, so are you guys trying to tell me this thing gives you problems? Katleho, Nontando, Coconut, Ntomizot, our one. I trust you guys. Where's Evelyn? I trust you. Guys, let's work this this step by step, ne? Unless if you guys are still on that unless if you guys are still working on that one. Tell me, can I continue? Did you try to attempt this? Just give me the answer on the comment. Should we continue? What is shy? What's wrong? What's wrong, Coconut? Is it difficult to solve this easy problem? I'm lost also. Yes. Okay. Don't tell me even the grade 12s are lost. Do you have any grade 12s? I'm still working on it. Do you guys have any grade 12s here? Don't tell me the grade 12s are also lost, because this is grade 11, you see. So now, if you are a grade 12 learner and then you understand what we are doing, it's going to be easy to solve the grade 12 one. I'm going to give you the tips on your lesson. Ne? Oh, Amahle got it. Yes, sir. Yes. Okay, stuck. Okay, let me help those who are stuck. First thing first, let's change the sign. Ne? Let's change tan. I'm going to change that tan and write it as the sine of x over the cos x. Okay, I can see that part. Then I'm going to add that cos x over 1 plus sine x. This is my left hand side. I need to work with my left hand side. Ne? Bonnie, you got it. Okay, it's fine. Let's work on it. Ne? Okay, so now I'm going to say from this, ne, I need to find this guy, what we call LCD. I'm not sure if you understand when I say we need to find LCD, the lowest common denominator, LCD. So I'm going to write it down and say LCD, it's equal to, remember, LCD is got the same denominators though. Okay, yes, say I used LCD to try get one denominator. So you'll say it's not easy. Coconut, no, it's easy. Let me show you that it's easy. Listen, pay attention. This is easy. This is easy, and I'm teaching you how to be smart. Ne? Remember, when you have fractions, you have two fractions. You take this denominator, which is cos x. Then you're going to multiply with what? With this denominator. Make sure that you take everything on your denominator, which is 1 plus sine x. So your LCD is cos x multiplied by 1 plus sine x. That's your LCD. LCD is the product of your denominators. You take your denominators, you multiply them. Okay, everything is good now. Then, when you have your LCD, you're going to multiply every term with that LCD. Ne? We're going to take the cos x into 1 plus the sine x. We need to multiply what? We need to multiply the sine x over the cos x. Then we're going to write that plus sign. Then we take the cos x into 1 plus the sine x. We need to multiply what? We need to multiply the cos x over 1 plus the sine x. This is easy, guys. What I did here, I just have my LCD. I multiply everything on my LCD. I multiply every term by LCD. When you are done, don't forget to divide everything now. To divide everything by your LCD. What is your LCD? The cos of x into 1 plus the sine x. I'm just going to stop here and try to see if we have any questions. Guys, please tell me, do you guys understand what we did here? Are you all happy? Is everyone happy? Please continue. Do you guys understand what's going on here? Get in, guys. Get in. Get in. Get in. Is everybody happy so far? I got it. I'm grade 12. Yes, Christine. Well done, eh? Well done. Okay, so now, if everyone understands now, this is what I need you to do next. You're going to take this guy here. You see this cos. You look at your LCD. This cos here will cancel with that cos. So we'll be left with 1. We'll be left with 1. This 1 plus sine x here will cancel with that 1 plus sine x. Then we're left with 1. We're left with 1. Then we need to multiply out the brackets. We're going to take this, multiply it with that. We need to take the cos, multiply it with that. So what are you going to have on top? Let's look at this now. I like trigonometry. So I'm going to say I have sine x. Okay, let's put it on top. We have sine x. That is multiplied by 1 plus the sine of x. Close the bracket. We have that plus. We have cos x. That should be multiplied by the cos x. Everything is divided by our LCD. We are getting there, guys. We are getting there. So now I think today you learned something about LCD. Né? Someone is asking, I'm not sure what you are saying, Coconut, when you say, why don't we just say sine x multiplied by just 1 plus sine x? You know, oh, no. I don't want to multiply out the brackets yet because I don't want to confuse anyone. I'm going to take this step by step. And then I have Bonge Kile, Snentanta saying, how does tan change to sine? Guys, tan change to sine over cos. Not only sine, this tan is it changed to sine over cos. Please pay attention. Eh? It changed to that one. So yeah, then now the next thing is to multiply out the bracket. Look at this. Now when we multiply out the bracket, I'll have sine times 1, which will give me the sine x. Then I'll have sine times sine x, which will give me positive the sine squared x. Okay, I'm happy with that. Plus I have the cos x times cos x, which will give me the cos squared x. Everything is divided by the cos x into 1 plus the sine x. Okay, everything is good. We have an identity on top. Né? What type of an identity do we have there on top? Look at this. I have an identity that says sine squared x plus the cos squared x. This should be equal to 1. So I'm going to take this guy and that guy, I'm going to substitute that as 1. So the top part will be sine x plus 1. So when we are adding, the order doesn't matter. Né? So what I'm trying to say, the top part will be sine x plus 1. And everything is divided by what? The cos x inside the bracket 1 plus the sine x. So the order doesn't matter. The top part is the same as 1 plus sine x. And this is divided by the cos x into 1 plus the sine x. So now I know that I have common terms here. Common terms that I have terms that are the same. I can cancel these two. I'm left with 1 on top and cos on bottom. So this is just 1 over the cos of x. Therefore, my left hand side will be equals to my right hand side. This should be easy. I think everyone is happy with that because Portia is happy already. Né? Portia said, I'm happy, sir, while we are not even done with the question. So I think, Portia, you did see where this is going. Né? I want to see more comments if you guys have any questions. If you are happy, then we can continue with the lesson. What do you guys think about the LCD method? What do you guys think? Are you all happy? Okay, it's fine. I don't see comments. Coconut say, I used a different method. I eventually got the answer. Coconut, which method did you use? Maybe we can learn something from your method. Guys, remember I told you, when you joined the family, we make sure that you feel at home. Né? Happy Heavenly said, is there another method, say? It's understandable. Got it. Yogi, you got it. When is the first time you comment? Say the LCD method only works adding or subtracting of fractions. Yes, the LCD works only when we subtract or we are adding a fraction. Thank you for asking that. Né? Amasi, I'm going to answer you now. Very happy we are flying. Thank you very much, Amingo. Katleho, yes. Okay, so now let's go back to Amas. Amas is asking that is there another method, but Coconut is not saying which method you used. Guys, I don't think there is another method that we can use except by proving the, what is this? Except by proving, what can I say? No, I don't have anything in mind now. It's okay, we use a different method to get 1 plus sin x is equals to 1 plus sin x. Kindness. Okay, I see your comments, guys. It's fine, we can continue now. It's fine, we can continue. Okay, it's fine, we can continue. We're just gonna work on trig equations now. We're just gonna work on trig equations. Okay, so now on trig equations, there are, if we quickly start with the basics now, if you master trig equations, there are things that you need to understand. There are things that you need to understand. Number one, the basics, the steps that you need to solve trig equation. These are the steps that you need to understand. First thing first, I need you to make sure that you isolate trig ratio. Guys, if you don't understand what I'm saying about isolating trig ratios, don't stress. Now this will make sense now. Number two, you need to find what we call RA, the reference angle. I'm not gonna write it on in full. I'm just gonna say RA, the reference angle. So now on this reference angle, the tip that I can give you is that don't put negative. Do not put negative into the calculator, please. Remember, I always tell you that the negative tells us which quadrant we need to work on. You're going to see when we do examples. So these are the steps that you need to understand. So number three, when we work on this, we need to choose a quadrant. We need to choose quadrant. The one that, the quadrant where we're going to work on. Okay, and then now when you are done with this, you'll be able to determine what we call the general solution. So on the general solution, we're going to say if it is sine or cos, I need you to add k times 360. So those who attended last week, we added 360 times n, which is the same as k times 360, but k must be an element of what? An element of integers. But if it's tan, if it's the tan, then I need you to add, if it's tan, I need you to add k plus 180, where k is an element of integers. Now, as your tutor, guys, as your tutor, né? Your favorite tutor, I'm just gonna leave you guys with a tip, né? I need you to remember this. Remember, only round off at the end. Same as finance. When you do finance, please make sure that you're rounding, you round off at the end, né? I hope everyone is with me on that, né? I hope everyone understands what I'm saying when I say only round off at the end. So how many identities do we have? Welcome, Fana. You are asking how many identities we have. It's fine, we'll list the identities when we work on them. It's fine, we'll list them, or I can also post the identities on the group net. Let's try to ask questions that are based on what we are currently solving, because now if I list all the identities, I think that we're going to waste like time, net. Right, let's try to focus on that. But the issue is that you guys are not tapping the screen. What's wrong? You need to tap the screen. Let's attract more viewers, né? Let's recruit more learners to join the family. And if you did not subscribe yet, make sure that you subscribe, and we'll make sure that you feel at home, né? If you are not part of the family, you can hit the subscription button, and I'll definitely make sure that you feel more welcomed. If I have 3, the sign of theta, and this is -1, and this is equated to 0, and they want you to do the general solution, guys, I'll start you with the basics, because it's very important that we know the basics. Okay, so the first thing that I can do now, why when I teach most of the time I start with the basics, I tell you that I don't have time for basics, but there are some of the topics where we need to discuss the basics, because you need to learn something from whatever that we are doing. So I'm trying to explain this step where it says we need to isolate. There's a step here saying isolate the trig ratios. So when we say isolate, we are trying to tell you that on your left hand side you only need what? The sine theta. So I can write this as 3, the sine of theta is equals to 1. So the 1 will go to the other side. I can divide both sides by 3. Therefore, what is the sine of theta equals to? 1 over 3. So when you have the sine of theta, I need you to find RA, the reference angle. We said that the reference angle will be the sine inverse of that 1 over 3. Then what is your reference angle equals to? What do you guys get when you punch that on the calculator? We are tapping. Oh, thanks. Thanks, Soli. So when you put this on the calculator, on my side I have 19.47 degrees. So this is my reference angle, but we need to actually solve for what? general solution. So now look at this. Now, look at this. What is given here? Look at this guy here. I'm going to say I have the sine of 1 over 3. So this guy is positive. In which quadrant is sine positive? First quadrant and second quadrant. So listen, if it's in quadrant 1, if this is in quadrant 1, so in quadrant 1 we say that theta is equals to the reference angle. We add k times 360 degrees, where k must be an element of integers. Then this is where we stop. So we just have to take the reference angle, then we add k multiplied by 360 degrees. We know that k must be an element of integers. So that is for quadrant 1. For quadrant 2, the second quadrant, we're going to take theta. We take 180 degrees. We minus what? Our RA, our reference angle. So we're going to minus that 19.47. Right. So when we work on this, what is the final answer? Let me not put it that side now. When we do this, we're going to have this as theta is equals to reference angle. I'm just going to subtract. So what I'm trying to say is that where there's RA, I'm going to subtract the 19.47. This will give me 180 minus 19.47, which gives us 160.53 degrees. Don't forget to add k times 360. And that's it. You are done. You are done solving for this problem. You are done solving for this problem. Now, so now what I need you to do, let's try and attack a different problem. But for this one, I think everyone is happy because this was easy. Now, thank you guys. I see your comments. Thank you very much. So now let's change this and say I have, let's assume that I have I'm given the tan of 3 theta plus 30 degrees. So that is my angle. Then we add 1 and this is equated to 0. What are you going to do? How are you going to solve this thing? How is this different? Guys, this is the same thing. The difference between these two questions is that here the theta is given as what? It's given as 3 theta plus 30. So remember, we need to isolate this guy here. We need to isolate that tan of that big angle. We need to isolate it, and the best way to do it is to move the 1 to the other side. This will be the tan of 3 theta plus 30 degrees. We're just gonna equate this to minus 1. Then now when you're done here, remember this is an angle. You will just have to find your RA, your reference angle, and then it's going to be the tan inverse without a negative. I gave you guys and said do not put a negative when you calculate the reference angle. So now this makes sense. Remember I said everything will make sense when we work on example. Do not put a negative into the calculator. Just leave it like this. Just leave it as 1. So the tan inverse of 1, you should get your reference angle to be 45 degrees. So the negative, it only tells you which angles to work on. Which quadrant should you work on? Look at this. Where is tan negative? It's negative in quadrant 2 and quadrant 4. So those are the angles that you need to work on. Remember in this one it's 180 minus your RA. This will be 360 degrees minus your RA. So we need to find the general solution. But now I have my angle as 3 theta plus 80 degrees. This will be equals to, for quadrant 1. So not for quadrant 1, should we say quadrant 3 or quadrant 2? Okay, let's start with not quadrant 3, let's start with quadrant 2. This will be equal to that 30. We're going to equate this to 180 degrees minus, remember, we take the whole angle that we have inside the bracket, we equate to 180 minus our RA, which is what? Which is 45. So I'm going to subtract 45 degrees there just to save time. This will be minus 45. We add K multiplied by 360. So this tells me that 3 theta plus 30 degrees is equals to 180 minus 45. What is that equals to? So 180 minus 45. I think this will give us 135 now. 135 degrees plus K times 360. I think now we know what is the aim. The aim is to find theta. We need to solve theta. I'm going to take the 30 to the other side. So this will be 135. We minus 30 degrees. We add K times 360 degrees. Remember this side we are left with 3 theta. So 3 theta is equals to 135 when you minus 30. That will give us 105 degrees. We still have plus K 360. So now we are looking for theta. I'll divide everything by 3. Remember what you do on the left hand side, you also do on the right hand side. So 3 goes into 105 35 times. Plus K times 3 goes into 360 60 times. So your general solution is what? Your general solution is this. So this is your general solution. Eh? So while we're on that part of the general solution, listen to this. Eh? This is your general solution. So now, let's say you are doing a past paper. Eh? And when you are doing a past paper, they give you this problem like this. And then they show this step. And then most of the time, they don't show this step. Nah? They don't show that step. They'll just say reference angle is 45. Then from there, they will never show all the steps. They'll just give you the final answer. And then now you are studying with a past paper and you have the memo. Still, you don't have a clue what is going on from the memo. So it's very best that you attend extra lessons so that you can understand how these things work. So now, when you see it like this in the memo, you see that, oh, K times 360, we divided that by something. So you can see that we've been trying to calculate the value of what? The value of theta, not 3 theta. I'm not sure, but maybe if you see, Ntombizotwa gave us tan K. Oh, okay. And Ntombizotwa said something serious, guys. Tan is not a 180. Why do we minus 45 with 180? I'm coming to your question now. Guys, this is tan. So since it's tan, we don't have to multiply this by 360. I was wrong by saying that this should be times 180. This is 180. Thank you, Ntombizot. You see now, this really motivates me, guys, because I can see that you are paying attention. I can see that everyone is paying attention. This should be 180, not 360. Okay, this should be 3. This should be 180 degrees because it's tan. This should be 180. This should be 180. You see this thing of running? We make mistake, a lot of mistakes. So the best way, guys, to solve these things is for you to understand things like when we say, how can I say this? How to solve trig identities. Now, you just have to know how to solve. So let me show you what I mean when I say you need to know how to solve. Let's say they give you something like, maybe I know that we did for this one And when you can work on this one, you know what you need to do now. You know what you need to do. You take this, you equate this to 360 minus reference angle. So someone was asking on the question, on the comments, that someone is asking, why do we minus 45 with 180? Why do we do that? Why are we saying 180 minus 45? Let me try and answer you now. Remember that we have this now, the tan of whatever that we have, the tan of this theta is equal to minus 1. So this sign here, it tells us which quadrant we need to work on. So the negative one, since tan is negative, we need to work on quadrant 2 and quadrant 4. So it definitely tells us which quadrant we should focus on. And we know that in quadrant 2, we take 180, we minus theta, and theta is our reference angle. This is the law of calculating general solution. This part here, you're going to say this is your 180, you minus because it's in quadrant 2. That's why we are saying 180 minus our reference angle. I hope Esona, you see now when I see your name, I remember that you gave me a problem on WhatsApp for us to work on it. I just forgot to do that problem. I think it's you, Esona. You gave me a problem, ne? You gave me a problem to assist you. I just forgot, but I did send the first question. The second question, I'll try to look at that question. Esona, we made a mistake. It's not 360, it's 180, ne? But guys, look at this, ne? Let's say I have 2 the sine of 2 alpha. We minus the cos of 2 alpha, and this is equal to 0. How can we solve for general solution? How can we solve this? I'm not going to do the general solution, but I can show you how to simplify this. First thing first, I need to move something to the other side. For example, I know that the cos is negative, so I can write this as 2 the sine 2 alpha, and this is equal to the cos 2 alpha. So now I know that, remember the tan of theta, it's equal to sine theta over the cos theta. So this tells me that I can just divide both sides by the cos of 2 alpha, so I can put my cos on the denominator. So look at the angles. The angles are the same, ne? Look at the angles. The angles are the same. So this will be 2 alpha, which this cancels, you are left with 1. And then this side we have 2 sine over cos, it's tan, and of that angle. So now what is the aim? Divide both sides by 2. What is the tan of that 2 alpha? It's 1 over 2. Now you find your reference angle. You see, this is how easy it is to solve the problem. You just have to make sure that you analyze the problem correctly. So let me check. Do you guys have any questions on that? Do you guys have any question based on that problem? Okay, so if you don't have any problems, I'm just gonna give you something that I need you to think about. If possible, just dream about this when you are sleeping. Or maybe I can just quickly show you. Then I just need someone who can say, no, sir, that's not possible. Look at this. Look at this. I have a proof like this. Let's say I want 1 minus the sine x over 1 plus the cos x. This is equals to 1 over the cos x minus the tan x and everything squared. So now guys, my question is that which side is the most complicated, or which side should we work on? Look at this sides. Which one should we both work on? Which side is the most complicated side? Okay, lost. Evenly, you lost where? Guys, let's go back. Everyone is lost. They are asking, where does the half come from? Let me explain this again. Remember, we are given this, né? Everyone is lost. Let me try and explain this again. Because now you see, we have a lot of learners who are left behind. Let's go get, I'm coming to get you guys. You are lost. I'm going to look for you, and I'll definitely find you guys. Don't worry, né? So now, we are saying that we have 2, the sine what? 2 alpha, né? Minus the cos 2 alpha, and this is equals to 0. So now from this question, we are moving the cos to the other side to be positive, né? So if it's positive, this will be 2, the sine 2. This will be what? This will be 2, the sine of 2 alpha equals to the cos 2 alpha. I think everyone still understands that part, né? Now, I can divide, because I know that tan is sine over cos. So since tan is sine over cos, I can divide this side by cos 2 alpha and divide this by the cos 2 alpha. What you do on the left hand side, you also do on the right hand side. So now look at what is going on this other side. Look at this. The cos and the cos cancel. We are left with 1 on top and 1 on bottom. So this is just equals to 1. Sine over cos, it's tan, and the angles are the same, so it will be just 2 alpha, and we have 2 in front. Remember, the 2 is over 1, which is just 2. So we need to make this tan subject of the formula. I can divide both sides by 2. So the 2 cancels. I'm left with the tan 2 alpha is equals to 1 over 2. Guys, please tell me on the comments, those who were lost, did I manage to find you guys? For those who were lost, did I manage to find you guys? So if you are still lost, you can comment, sir, is this the best you can do? If you are still lost, I need you to say, sir, is this the best you can do? Pella, we are really lost. We are really lost. You can do better. Please find us. Then I'll definitely try to find an alternative way to explain this. But this is the best way, trust me. Are you all with me? Do you guys understand what is going on here? Is everyone happy? Sorry. I'm found. Nice, Amingo. Okay, 100%, ne? 100%. Look at this. Look at this, ne? Look at this question. We need to prove that left hand side is equal to right hand side. So I'm asking, which side is the most complicated side? So to answer you guys is that my left hand side and my right hand side, both of the sides are more complicated. Both of them, they are more complicated. What I'm trying to say is that we need to work on the right hand side. We need to simplify the right hand side, and we also need to simplify the left hand side. I'm only interested in left hand side because there's something you need to learn here. Ne? Left hand side it has to do with rationalizing. What are we rationalizing? It's fine, we'll choose. I'll teach you which part to choose that you can rationalize. Someone can say I'll rationalize the numerator, someone can say I'll rationalize the denominator. So this is what I'm going to do now. This is what I'm going to do. I'll take my left hand side. I'm going to say this is equal to 1 minus the sine x, and this is divided by 1 plus the cos x. So now when we rationalize, I can multiply the top by 1. Oh, we are rationalizing the denominator, 1 plus cos x. So we need to multiply top and bottom. This is wrong, man. This is wrong. Please forgive me, guys. Let me fix this now. Imagine if we start our lesson from 4 p.m. We push until this time. I wonder what will happen. Okay, so now this is going to be 1 plus sine x. It's not cos, it's sine. So this will be 1 plus the sine x. So now I'll have 1 minus the sine x on top, 1 plus the sine x on bottom. So when we rationalize, we're going to multiply top and bottom by what? The reciprocal, the inverse, let me say the opposite of this. If it's 1 plus sine x, what is the opposite? The opposite is 1 minus sine x. So I'm going to multiply the top part by 1 minus sine x and the bottom part by 1 minus sine x. You see? And now when you have it, you can just row multiply and multiply the top part and also multiply the bottom part. So on top, we row multiply. I'll have 1 minus sine x. Put this guy inside the bracket. I'm going to multiply that with 1 minus the sine x. And what do I have on my denominator? 1 plus the sine x. We're going to multiply this by 1 minus the sine x. So you can use your FOIL method. Multiply out the bracket. 1 times 1, it's 1. Then I'm going to say 1 times minus sine x, it's minus sine x. Minus sine x times 1 is just negative the sine of x. Then negative sine x multiplied by negative sine x is just positive the sine squared x. So look at this. What I'm going to do, I can say the bottom part will give me, let's multiply out the bracket on the bottom part. I'll have 1 minus sine x plus sine x minus the sine squared x. I hope this makes sense now. I hope no one is lost here. And this will be 1 minus, on top I'll have 1 minus 2, the sine x, we add the sine squared x. That's the top part. The bottom part, I just have 1 minus the sine squared x. There's nothing else I can do. I can just leave it like this. Now, this is my left hand side. So if I prove my right hand side, if I work on the right hand side, I need to get an answer that is similar to that one. Let's go try to work on the other side now. Let's go and work on the other side. So I'm going to say that is my right hand side. It's given as 1 over the cos x minus the tan x, and we can see that this is squared. And now I need to simplify this now. I need to simplify this. So look at this. I can change the tan x into sine x over cos. So I can say this is the cos x minus sine x over the cos x. Now look at that. What do we have? We have squared. So I think everyone understands that what is this? The denominators are the same. We can write this as 1 cos x On top we subtract our numerators. So this is everything squared. So if I have a over b and everything is squared, this will be a squared over b squared. We square the numerators and the denominators. So we'll have 1 minus the sine everything squared, and this divided by the cos x everything squared. So on top we're going to expand the bracket, but look at this. I know that when I expand the bracket, I'll get 1 minus, I'll get this, which can be simplified to that. So I can write this as 1 minus 2 the sine x plus the sine squared x. I don't like learners who are going to write this thing many times. We already know what is 1 minus sine x because we did it on the left hand side. We know that 1 minus sine x squared, we are expanding the bracket. When we multiply out the bracket, this is the answer that we get. So I can just write it as 1 minus 2 sine squared x, and on bottom I'm left with what? The cos squared x, which can be changed into 1 minus sine squared using the identity. So this is just 1 minus 2 the sine x plus the sine squared x, and everything is divided by the cos squared x. Therefore, left hand side and right hand side are equal. Now this is where I expect you guys to ask questions. The bros. Hey guys, some of your names. Yo, what's wrong, guys? What went wrong? The bros. Like amen. What is that? Welcome, Fana. What's wrong, guys? Are you guys lost? What's wrong, guys? Is everyone happy with that? Okay, Nube is asking, say, why and when do we have to rationalize? What are we proving, sir? Because left is not like right. Hey, man, guys, is left not like right? Am I missing something? Oh, I'm sorry. We forgot to change this. Sorry, ne? We forgot to change the cos squared x. Remember the cos squared x, it's what? The cos squared x can be written as 1 minus sine squared x. So this is 1 minus the sine squared x. So these two guys, they are equal. So left hand side is equal to right hand side, ne? Yes, even on trig, Baba, you can rationalize the denominator. How? You remember you did this in grade 11, ne? The grade 11s, yes, they are rationalizing. We also rationalize in trig. So someone is asking, when do we rationalize? The best way to rationalize, let me tell you, is that we rationalize when we have this type of a problem, where we have one fraction, but it's 1 minus or 1 plus something over, and the sign should be different. The top one and the bottom one should be different. That's when we do the rationalizing. Eh? That's when we rationalize. So if you guys are happy with that, yeah. Need more. You need more practice, ne? What were we proving? Circles left is not right. And Tomizota, can you agree with me that left hand side and right hand side are equal now? Okay, so now Okay, guys, I'm waiting to see if everyone is happy. I thought we were going to get one and from the top answer. Oh no, listen, when you have this type of problems, most of the time in trig ratios you'll be required to prove left hand, you'll be required to prove that left hand side is equals to, oh, I'm sorry, you'll be required to prove that both sides are equal. In most cases, you'll be required to prove that both sides are equal. Okay, so if everyone is happy, then this is the time where we're going to work on a past paper. Trigonometry, get in. So if you are in the lesson, make sure that you stay with us so that we can work on a past paper. Let me quickly open the past paper. Guys, did you all write investigations yet? Yeah, those who have not yet write the investigations, maybe you can reach out to me. If you know the topic, then I can assist. Let me quickly do this. Okay, let's go get the past paper. Just give me a second, guys. I'm just gonna go get any past paper that we can work on. Okay, we're going to look at this problem. Let's see if we'll be able to answer the problems. I just want you guys to see, okay, this is a past paper. We need to go to trigonometry and see what we have on trigonometry. So can you please guys confirm on your or on the comments if you can see the screen, then we can start answering the questions. I'll definitely give you guys a practice problem relating to rationalizing. Okay, let's see on the chat box who agrees with Amigo. The Amigo. Amigo is saying I should give you guys time to try this problem, then help with corrections. So do you all agree that we should do that? Do you all agree that I should give you time? Come on, guys. I'm waiting for your comment. Okay, work on it first, né? Work on the problem first, then we'll try and answer this question. Work on it, guys. You see, lazy learners are going to sleep. We're going to have the last man standing. I'm not even sure if they will be able to work on our exam preparation program. Yeah, we're still thinking about that exam preparation. I'm just gonna update you guys, don't worry. Just help us answer, sorry. Yeah, the amigo, you are very funny, straight now. You are very funny. So he's saying that I should just help you answer, guys. Now, let's answer this question. Let's answer the question. It's fine. We're going to answer the question. How 2 minutes to meet already? Okay. So to answer this question, what I'm going to do, I need to reduce the cos of. I need to reduce the cos 210. Né? So this will be the cos 210. I need to reduce that. I'll check in which quadrant is 210. It is in quadrant 3 because it's between 180 and 270. So I can say this is the cos of 180. We need to add something. So this will be the cos of 180. What can we add to 180 degrees to get to 10? We can add 30 degrees. Then we'll multiply this by the tan. We still have 210, which is also in quadrant 3. This is 180 plus 30 degrees. So the bottom part, I'm going to leave it as what? The bottom part will be the sine, and this is squared into 180. We need to add 45 degrees to get that. Né? So when I have this problem like this, I can just reduce the top part. This is in quadrant 3. And how is cos in quadrant 3? Negative. This will be negative the cos of 30 degrees. What about tan 180 plus theta? That's in quadrant 2. So the one in quadrant 2 is what? In quadrant 3, so the tan is positive. This will be positive, the tan of 30 degrees. Right. Then when I have it like this, I can just divide this by the sine. Okay, this is quadrant 3, sine is negative. This will give us the sine squared of 45 degrees. That's how easy this problem is now. So when you punch this on the calculator, we are definitely getting something wrong. Né? There's something wrong that we are doing here. Remember this other time we talked about the square root. So let's fix this. The sine squared of 180 degrees, we add 45. Remember, we said we can write this as the sine of 180 plus 45, and everything here it is squared. So the square squares everything. So this will be negative the sine of 45 degrees. Remember, everything is squared, which will give us positive the sine 45 degrees. We need to get rid of that negative. So if we put the negative, it's wrong because the squared will remove the negative. So when it's like this, then we can work on it. You just have to punch the cos 30 on your calculator. You'll get negative the root 3 over 2, which is multiplied by the tan 30. If you put root 3 over root 3, this you're going to definitely get it wrong. Né? So we need to put this as 1 over root 3 and divide this by the sine 45, which is 1 over root 2, and this is squared. They said without using a calculator, the top part will give me root 3 over 2 root 3, and then this is divided by 1, listen, 1 over 2. This is just 1 over 2 if we simplify it. The root 3 and the root 3 cancels. We are left with what? We still have the negative part there. We are left with 1 over 2 divided by 1 over 2, which is just negative 1. So the answer is negative 1. Yay! Sesekake. Yay! Sesekake. I just want to answer Ntombizotwa. Ntombizotwa is asking, are we wrong to be used the cos of 360 minus 150? Why do we bring 150? Because 150 is not a special angle. If we bring the 150, we are complicating things now. If you bring the 150, you are complicating things. Okay? Let's not bring 150. It's fine if we use special angles. Let's look at what we have on the second one. Look at this. This one has to do with the reductions. Ne? Yeah. Let's see what we have now. Sine of 360 minus x. This is in quadrant 4. How is sine? Sine is negative. So I can write this as negative, the sine x. Right. Then multiplied by the tan of negative x. Remember, if this is my Cartesian plane, negative theta is in quadrant 4. So tan in quadrant 4 is negative. We're going to write this as negative tan x. I'm doing the reduction formula. Minus theta again. The cos of minus x. This is quadrant 4. How is cos? Cos is positive. This will be positive, the cos of x. We are dividing this by the cos of 180 plus. 180 plus, it's in quadrant, this is in quadrant what? This is in quadrant 3. How is cos? The cos is negative. We're going to write that as negative, the cos x, and then multiply this by the cos of 90. So, because it's a 90, this is a cofunction. Remember, if I have a 90 here and I subtract, I'll go to quadrant 1. Cos is positive. This changes to sine x. So remember, we talked about cofunction. When we do the cofunction, okay, it's fine. So this will be sine x. So cos changes to sine because this is a cofunction. So you know what I'm going to do? Because I don't like making mistakes. Nah? Trust me, you are allowed to do this because this is multiplication. You can look for terms that can cancel, the ones that can cancel, the ones on the denominator. Look at this. This guy, that guy cancel. The negative will cancel one negative there. The sign and the sign. We are just only left with what? Negative the tan x. I think this is where you can stop. I think this is factorized like that. So now, how many marks? Maybe it's best if I show you guys how they mark this problem. Ne? Let me show you. Look at the marks. Ow. Yo, guys, come on, please. Don't fight with me. Make sure that you don't lose those marks. 6 marks. Let me show you how they'll mark this. Ne? I think this is just marks. They are giving us those marks. So you'll get 1 mark for reducing that. 1 mark for reducing. 1 mark for reducing. 1 mark for reducing. 1 mark. That's 5 marks to reduce. Then you'll get a mark for the final answer. I hope this makes sense, and I definitely hope everyone is happy with that. Ne? Are you still with me, guys? You see, everything that I show you, everything that we discuss, everything, it's what you're going to get in your exam. everything that we do. Evelyn, what's wrong? Are you just surprised how they're gonna mark that problem? It's easy to pass, trust me. You see, it's easy. Just understand the reduction formula and how it works. Then you'll see that to pass it's easy, man. It's easy. You just have to focus. Then you'll see Luen. You just have to focus. Marks just like that, yeah. Just like, but I know there's still someone who's going to donate those marks. They give you the mark, why not? Because you have enough marks, you just give them back. You say, you know what? I think we can take this one to charity. I think I have enough marks for the day. Then you take the marks, you give it away. Don't do that, ne? Don't do that. So now, on the next problem, they say that if the cos of 63 degrees is equal to P, determine the value of the following in terms of P without the use of a calculator. We talk about the aid of a diagram. We talk about drawing a diagram. This is where it all starts. We're going to start by drawing a diagram. Very important. We talk about this, drawing the diagram. So I'm just showing you. If you understand what we are currently doing on our lessons, then you are good to go. Don't worry. That goal mark of 70% is nothing. When I just make sure that you follow the instruction. Remember, on our lessons, the first instruction that I gave you guys is to make sure that you draw the correct diagram. How do we draw the diagram? We're going to say we are given the cos of 63 degrees. It's equal to P. So now there's no conditions, there's nothing. How do we know which quadrant is correct for us to use? We look at the angle 63, it's in quadrant 1. So our triangle will be in quadrant 1 like this. So this will be my 63. That's my angle, this is 90. If this is 63, I need someone to help with the calculator, because I don't have my calculator with me. If this is 63 and this is 90, what will be that angle equals to? Sum of angles in a triangle. So we're going to say 180 degrees minus 63 degrees minus 90. The answer that we get is the third angle. What do you guys get on your calculators? Please assist with the calculator. What do you get? And Tombizota, thank you, that was fast, ne? Thank you, that was fast. So now, thank you, that was fast. So now, don't worry guys, when we finish this, they say that this angle is 27, so I'm just going to write that angle is 27 degrees so that we don't forget. Ne? So remember, the P, any number, it's over 1. So I'm just going to write that P as a fraction. So this is over 1. So what I'm trying to say is that the cos 63 degrees is equals to P divided by 1. So cos is according to the SOHCAHTOA. Cos is adjacent over hypotenuse. So we have X, we have R. Before we answer any question, we need to find the missing side. So R here, it's 1. Y, we don't have that 1. Then we have X to be P. We need to use theorem of Pythagoras to find the missing side. So R, it's 1. This is squared. It's equal to X is given as P. This will be P squared plus Y squared. So the P comes to the other side. We have this as Y squared. We square both sides. We square both sides. Therefore, what is Y equals to? Y is just plus or minus the root of 1 minus P. But I'll just write it as positive because this is in quadrant 1. So Y is positive. We have Y, we have R, we have X. We can answer the following questions. Ne? Yes, thank you, Ntombizota. That's correct. Root 1 minus P squared. So I have the cos of 117. I need to remember, in order for us to use that diagram, we need to have an angle of 63 or 27. So how can we get an angle of 63? The first one, we can write this as the cos of 180. What can we subtract from 180 to get 117? We can subtract 63. You see, that's how, that is what you need to do. You can just substitute that 63. Look at this. We started as in like we are playing, but look at now, we are cruising nicely and we are doing past paper. So now, you remember why I said the reduction formula is important. We started doing the reduction formula. Now we're going to apply it on the exam. So look at this. This is in quadrant what? 180 minus theta. That's quadrant. That is in quadrant 2. So how is cos? Cos is negative. So this will be negative. The cos of 63 degrees. Because it's 63, we can use the diagram, but don't go far because the cos was given there as p. So this will be negative. The cos of 63 is just p. Then you're done with the first question. You'll have your 2 mark. Let's go back to this one. The sine 27. You see, do we have 27 on the triangle? Yes. But now look at this. If our triangle is like this is my triangle, and we have this as 63 here. Guys, please tell me if I'm moving fast enough. And this here is 27. So this tells you that this changed everything. Your x this time is 20, and your x will be that root 1 minus p squared. And this time your y will be p, your r will be 1. Why? Because we are changing the angle. So this becomes your adjacent, and the other one becomes your opposite. Guys, I hope this makes sense, né? I hope this makes sense. This guy here, this angle becomes your adjacent, and this angle becomes your opposite. So to find the sine of 27 degrees, we're going to say this is opposite, which is p over hypotenuse. So the answer is just what? So the sine 27 is also equal to p. Easy, né? It's easy. Right. What about the tan 1143? You know, the way maths, you see, maths can make you say that when you are in an exam, you'll be like, they make a mistake. Baby, the one make a mistake. Let me just remove the 1. There's no 1 there. No. Just work the question the way it is. Don't try to change the question. Né? They did not put the 1 by mistake. Né? They definitely reviewed the question paper more times, and if there were issues, they definitely saw that problem and they fixed it. When I work on it the way you see it. Né? So if I have this, I'm just gonna add 360, or subtract, né? And that's it. You can just subtract. You subtract, you subtract, you subtract until you get what you are looking for. Right. So if you do this, you'll find that the tan of 1143 on your calculator is the same as the tan of 63 degrees. They are equal. They are the same. You just have to use your magic to reduce this. But don't worry. Just say these two, they are the same. So tan is opposite all over adjacent. Remember, we had a diagram in first quadrant like this, and this was my y. It equals to root 1 minus p squared. And we had x, which was p. So tan is opposite, which will be root of 1 minus p squared over p. And that's it. You are done solving the problem. This is 4 marks. So if this is 4 marks, remember, you'll have the mark for the diagram. Then you'll get the mark for the correct substitution. I hope my learners are happy, ne? I hope you guys are happy. Last man standing. Who's this? Lindelwa Dlamini. Arsene. What's wrong, Lindelwa? Lindelwa, what's wrong? You good? Look at Evelyn. Evelyn gave you guys, say, minus 360, minus 360, minus 360. You'll get that 63. So you're going to minus 360 3 times. Evelyn, you guys are lying. You are learning. You are not playing. You are learning. Tandy, which part do you want us to explain? If you are lost when we say tan 1143 is the same as tan 63, look at what Lindela did. Where do we get 63? Guys, where is the 63 coming from? Remember, the 63 is the angle that we were given, so we need to make sure that before we refer there to that triangle, the angle is 63. So the 63 is coming from saying this is the tan of 1143 minus 360 minus 360 minus 360. So this can be, it's equals to the tan of 63 degrees. Okay. Let's quickly work on the last question so we can call it a day now. Okay, so the last question, I just want to go to an identity part, but I'm not going to do this one. I think we did this, but it's fine. Look at this, guys. Remember I said everything that we work through on our lessons, please pay attention, because those are the things that you'll get in an exam. We just did this, and I've showed you guys how to work with fractions, how to prove if we have a fraction. First thing first, you need to find your LCD, and we said LCD is the product of what? Of the denominator. So we're going to take 1 plus sine x, we're going to multiply that with the cos x. So this is my LCD. Then we are working with the left hand side, the most complicated side. We need to take that left hand side. We need to do what? We need to take the left hand side and prove that it's equal to right hand side. I hope this makes sense. Né? So we take our LCD, which is 1 plus the sine x into the cos x. We need to take this, we need to multiply the cos x over 1 plus the sine x, right? Therefore, we have plus, we need to take 1 plus the sine x, we need to multiply what? We need to multiply this with cos x, then we take this and multiply it with 1 plus the sine x over the cos x. Right, everything is divided by our LCD. Please remember, don't forget this. Né? Everything is divided by our LCD. And what is our LCD? Our LCD will be that 1 plus the sine x, close the bracket, into the cos x. I'm just going to work this thing out now. I'll say that 1 plus sine x and 1 plus sine x cancel. Then I need to multiply these two, the cos x and the cos x. So I'm just going to save time and write this as the cos squared x. The cos and the cos cancel. We need to multiply these two. But remember, this is like saying 1 plus sine x. We need to multiply it with 1 plus sine x. You see, 1 plus sine x is multiplied with 1 plus sine x. So it's going to be 1 times 1 It's 1. 1 times this will give us plus sine x plus the sine squared x, and everything is divided by our LCD of 1 plus the sine x. Guys, I know everyone know how to multiply the bracket by now, so you just have to multiply the bracket so that you can combine the like terms. This is just 2 sine x. So the top part I have, look at this. The top part, what do I have? I have the cos squared x plus 2 the sine x, we add the sine squared x. Everything is divided by our LCD of 1 plus sine x into cos x. So now I think I'm lost here. Né? I think I'm lost. I'll go back to my proof and try to compare what I have with my right hand side so that I can have an aim or a goal. So on top I need 2. I need to get 2. So on top I need to get 2. How can we get 2 on top? So now this tells me that I know that I can say, look at this, we can change the trigonometry. Now just to save time, I'm not going to write everything on the board here, but I'm definitely going to show what you need to do now. You see this cos squared and sine squared, we can group these two guys. If we group them, they will give us 1. So this tells us that the top part is just equals to 1. The top part will be equals to 1 plus 2. Is this right? Wait, where's that 1? What happened to our 1? What happened to this 1? So we still have plus 1 plus sine plus 2 sine x. So this will be 1 plus 1 plus 2 the sine x, everything divided by 1 plus the sine x into the cos x. So on top we can add 1 and 1. Ne? So the top part can give us 2 plus 2 sine x over 1 plus the sine x, the cos x. So look at this. We can take out the common factor on top. Ne? We can take the common factor on top. We can take 2. We left with 1 plus sine x over 1 plus sine x, which will be multiplied by cos x. Look at this. These two cancel. The top part is 2 over the cos x. Your left hand side is equal to right hand side. Guys, why I feel like I'm rushing? Like in Kari, we forgot one. Yes, thank you. Jax Yogi, what is JDGPD and what are you saying? Thank you, amigo. I forgot one. So this is left hand side is equal to right hand side, and this is how you do it. Né? This is how it is done. So I'm not sure, should I leave the general solution for you guys to master it, because you guys now are the best. Because now I don't want you guys to stress. Now this is 3 marks. Remember, look at this question. When it's like this, you're going to say you need your RA, your reference angle, because already the trig ratio is isolated. What is the reference angle? What will the reference angle be equals to? So I think we made a mistake by bringing this back. They are disturbing us. Yes, we made a mistake. What will the reference angle be equals to? You see, it's going to be the cos inverse of 0.3 without a negative. Please don't put a negative. Né? Now tell me, guys, what is the cos inverse of 0.3? Can you please send your answers on the calculator? What do you get? What is the cos inverse of 0.3? Because we first start finding the reference angle. Last man standing. 15 learners left. from 60 learners, 15 learners left. $72.54. Thank you, Ntombizota. We are done. Don't worry, ne? Everyone will go to sleep. Others, we move to TikTok. We're going to work on that other side. So now, if it's like this, it's going to be, what is this equals to? Come on, guys. I said without a negative. Why did you guys put a negative? Okay, so RA, theta minus 30 will be equals to that RA. So where is cos negative? So cos is negative in quadrant 2 and 3. So I'll work with quadrant 2 and I will work with quadrant 3. So we're going to say 180 minus RA. We're going to minus that 72.54 that you guys got. Then we need to add k times 360. But remember, k must be an element of integers. Now I have theta minus 30 degrees. It's equals to 180 minus 72.54. When you minus these two, what is your answer? What do you get? What is 180 minus 72.54? I think it's close to 7 point something. 100 and something, ne? 107 point what? 107.46. Then we add k times 360. Then we need to take the 30 to the other side and say 107.46. We need to add 30 plus k times 360. That's your general solution. Then you are done. If you prefer to do the other triangle, you can work on it. So if we add this should be 137.46 plus k times 360 degrees. And that's it. Let me see. Come on, guys. We still have another one. I'm tired. Thank you. I see you guys gave me the correct answers now. Okay. Okay. Well, that's the last one. Okay, this will be the last one, but I think I'm just gonna leave you guys with this one to practice. Remember how we do this, ne? Come on, guys. Everything that I show you guys, it's on the paper. Remember, I have sine 2x. Come on, guys. This is what we were doing here. Let me go back up, ne? Which one? Okay, this is what we were doing during the day. Okay, during the day. Come on, guys, look at this. This is what we did exactly on this lesson, and it's on the it's exactly like this on the past paper. Yes. You see now, if you don't focus on our lessons, and you'll be like, I did see this on the lesson, but I didn't understand. So if you don't understand, ask questions. Yeah. So now, what I'm going to do to solve this now, the best thing to do, this is given like this. For the cos 2x, remember we divide both sides by that cos 2x, divide that by the cos 2x. Now the angle are the same. Sine over cos changes to the tan. This will be the tan of what? These two cancels. The tan of 2x is equals to 4. So now when it's like this, you can find your reference angle, which will be the tan inverse of that 4. You punch it on the calculator, you find your reference angle. So you're going to say that 2x is equals to, where is tan positive? quadrant 1 and 3. So in quadrant 1, we just say RA, we add K times 180 degrees. So now, what did you guys get when you punch your reference angle? Reference angle is 75.96. We add K times 180 degrees. So this is 2x. We are looking for x. We need to divide everything by 2. So the x is equals to 75.96. So we know that 75, half of 75, it's 30. What is half of 75? I don't think I can do this without using a calculator, but you can work on this and find the final answer. Ne? Half of 75. What do you guys get when you say half of 75.96? 37. 37.98. Thank you very much. 37.98 plus K times 180. All done. You'll get your 6 marks. Easy. Easy, 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 easy. Thank you very much for those who stayed until 0:00, ne? Until 0:00. And now we're going to work on physics on the other side, ne? I just need a moment. Those who are sleeping, good night, ne? But I see Amigos tried to say something. 60 to 23 like a grade 10 science class going to grade 11. Okay. Alright, thank you guys. Do you have any questions based on what we've covered today? So I know that we're going to, I have 20 last standing students. So the program that we're going to start should start with 20 learners. Ne? I'll explain the program on the WhatsApp. It will start with 20 learners, because if someone can stay in our lesson for 2 hours, we only need those who can stay, like who can do 3 hours per week. 180 divided by 2 is 90. Thank you very much. Ne? 180 divided by 2 is 90. Yeah, I see you guys are working on your side. Ne? This is 90. Please make sure that you don't repeat the same mistakes in grade 12. Please, yes, we'll work on grade 12. We'll be doing grade 12 physics in that other side. Thank you very much for those who, for everyone who joined today. Ne? This is where we're going to end the live. Thank you very much, guys. I'll see you on our next lesson. And have a great evening. Sharp, sharp. Yes, yes. Views 379.